Good afternoon. Welcome to the Amazon Web Services webinar. And the topic for today is launching your first big data project on AWS. We thank you for making the time to attend the session. You can post your questions in the chat box throughout the presentation. The questions would be answered during the Q&A session post the presentation. Our presenter for today is Robbie Thomas, Solutions Architect, Amazon Internet Services. Over to you, Robbie.
Thank you, Vidhi. And once again, I thank all of you for taking the time out to join this webinar, which is about launching your first big data project on AWS. During the course of this webinar, we will talk about using various AWS services, Amazon Web Services, to build an end-to-end big data application. Some attendees may already be familiar with Amazon, but there are also attendees who are not very familiar with Amazon. So I'll try to make it as generic as possible. Okay, so without further ado, let's get started. So before we get into specifics of services, I just want to spend a couple of minutes talking about big data itself. And one of the things that I've noticed working with customers and partners in the big data space is that many customers actually worry a lot about the tools that they use. They wonder about whether I should use this tool, should I use Hadoop, should I use a data warehouse service, what storage should I use, and so on and so forth. But I think it's more important to actually focus on the business use case, and this is kind of becoming more and more clearer to more customers as we proceed. So think of basically you can think of it as data in and data out, and there may be many components required in between, which you can actually pick and choose and plug in and actually make a full big data pipeline, which at the end of the day takes data from various sources and gives you a business insight, and that's pretty much what we actually do. And we'll try to actually build a mini application today that kind of emulates that. Okay. So there are various stages in this. On the left-hand side, you can see that there is a data collection and storage phase, which there are many services in Amazon Web Services that actually help you with this. So we have Amazon S3, which is a highly scalable storage service. We have Amazon Kinesis, which is kind of like a buffer or a queue into which you can put in data that is being generated while you figure out what you actually want to do with it. We have Amazon DynamoDB, which is a highly scalable NoSQL database, and we also have the relational database services. We also have in between, in the data processing layer, we have Amazon EMR or Elastic MapReduce, which is essentially managed Hadoop. We'll talk more about EMR as we go along, and there are also other services for analysis, like a data warehouse service called Amazon Redshift, a highly scalable petabyte scale data warehouse service, and we also have Amazon Machine Learning. So for today's big data application, we actually will be ingesting logs that we generate, web server logs, and we'll be ingesting that into Amazon Kinesis. Amazon Kinesis, you can think of it like a buffer or a queue. Basically, when you have a lot of data being generated, you need to stage it somewhere. You essentially are decoupling the producers from the services and infrastructure that actually process the data. Right? So you want to actually stage it somewhere while you're pulling off the data. So the data goes into Amazon Kinesis, and from Kinesis we will persist the data into Amazon S3. Amazon S3, think of it as a very highly scalable and durable storage service into which you can dump any files, so starting from one size of 1 byte up to 5 terabytes. And from Amazon S3, we used Amazon EMR, which is a managed Hadoop framework, to process the data, to basically take the data apart and move it and modify it into a format in which you actually want to visualize it. And from EMR, we actually move data into Amazon Redshift, which is a SQL compliant data warehouse service. And towards the right, we actually visualize it using various tools. So on the right-hand side, there is a service that has been announced, Amazon QuickSight, which also helps in visualization. But today we'll be actually using a client-side JavaScript to just visualize the data. So this is going to be the application. So let's get into details of each of these services that we actually use. Okay, so the first stage we actually will be ingesting data into Amazon Kinesis, and we'll use Spark streaming. Okay, so Spark is a framework on top which actually runs on top of Hadoop, which can actually actually read streaming data from Amazon Kinesis, and we use Spark streaming to pull data that is being staged in Kinesis and then persist it into S3. So you have incoming data and you're using Spark streaming to actually pull that data and persist it into a durable storage, which is Amazon S3. Right? And the next stage, we will actually use Spark itself instead of Spark streaming to pull data from S3 and process the data. The actual processing we'll be doing today is kind of very minimal, but you can you can actually do very intense processing and very complicated processing on your data as well using Spark. So Spark is one of the newer frameworks that have come along with Hadoop, and so we'll be using Spark for this. From there, we'll actually be loading data from S3 into Amazon Redshift, and we'll be visualizing the data in the last stage. Okay, so there are three distinct stages. So let's get started with setting up all the pieces of infrastructure that we actually need to start this processing. Right? In the first, we actually create a Kinesis stream. Like I said earlier, Kinesis is a data ingestion service. Think of it like a buffer or a queue into which you will dump data while you figure out what you want to do with it. You want to pull it off and then process it later. But this is essentially a buffer where you can actually stage your incoming streaming data. Okay. In this, we will actually create, in Kinesis, we'll create a Kinesis stream. And in Kinesis, for scalability, there is a concept of a shard. So each shard can actually ingest data at 2 megabytes per second, and you can pull data off it at 1 megabyte per second. And if you want to actually ingest more and more data, you just have to increase the number of shards that are there. So that's going to be the first step that we do. And we'll just create a single shard Kinesis stream to start with. And next, we'll actually create an S3 bucket. Okay, so like I said earlier, S3 is a highly scalable and highly durable storage service into which you can practically put files of any size. It scales automatically and you pay only for what you use. You can create a bucket. We'll create a bucket in S3. Think of a bucket as a placeholder or a folder into which you can just dump files of infinite size. Right? And next, which is kind of a little more complicated, is we will actually create an Amazon EMR cluster. So what is EMR? So EMR is essentially managed Hadoop. So people who know Hadoop consists of basically a master node. It's a cluster that's created of a master node, and there are various data nodes into which there are various data nodes and task nodes that actually create the cluster. Essentially, it consists of two parts. When it started off, there was a HDFS or Hadoop Distributed File System Storage, which is a distributed storage that runs across all the data nodes in the cluster. And there is an execution framework called MapReduce, which was part of Hadoop, the first version of Hadoop. Now Hadoop has kind of evolved, and there is the new versions of Hadoop, which actually uses Yarn, which is, think of Yarn as a resource manager that actually takes care of distributing jobs or basically tasks given to the cluster across multiple machines in the cluster. Right? Another thing that we have actually seen is you can also think of Hadoop like Linux distributions. Right? So if you work with Linux, there are various distributions. You have Debian, you have Ubuntu, you have Red Hat, and so on and so forth. Similar to that, Hadoop also has various distributions that are kind of the same, but also have their small differences and different tools and so on and so forth. So in Amazon EMR, we actually support two distributions. We support a commercial distribution of Hadoop called MapR, We also support an Amazon distribution. We use essentially the open source Apache distribution of Hadoop with some tools that are there included that integrate with the Amazon ecosystem. So in this instance, we are actually going to create a two-node cluster, two-node MapReduce cluster, and we will actually be also bootstrapping some programs. If you look at the command here, it actually at the bottom you can see we are actually installing a couple of applications called Hive and Spark. So Hive and Spark are all applications that run on top of Hadoop that allow you to do various things. For example, Hive allows you to actually write SQL-like statements on data sitting in Hadoop. So even though Hadoop is not a database, you can actually interface with it. You can actually query data that is actually sitting in your Hadoop cluster, or even data sitting in S3 as well via the Hadoop cluster. So it's possible to do that. Okay, so we shall be creating a MapReduce EMR cluster as well, which is nothing but a Hadoop cluster. And towards the last component, we'll actually create a single node Redshift data warehouse cluster. It doesn't have to be a single node cluster. You can actually create a cluster of up to 120 nodes, or which can support up to 2 petabytes of data storage. Redshift is a well-oiled data warehouse. It is SQL compliant, and you can load data into Redshift, and you can execute queries on data with tables with billions of records, and joins with tables that have billions of records. It's an extremely fast data warehouse service that's available. So without further ado, let's get started with creating the cluster. I'm going to go to the command line. I'll try to increase the size of the command line so that you can have a view. So I'm going to actually log on to one of my machines. You can also use your own desktop for this. So on this machine in Amazon EC2, I have installed the Amazon CLI. So to create all of these services, as you saw earlier, we were actually using commands. You don't have to use the commands. You can actually do whatever I'm doing from the CLI using the console itself. But I just want to demonstrate how easy it is to actually create all of these services with just commands. Right? So let's go to the AWS console first. I'll log into the AWS console and show you and navigate to the various services. So first, we are actually going to create a Amazon Kinesis stream. And as you can see, there are no streams in my console as of now. And I go ahead and create a Kinesis stream. And refresh the page. Yep. So I've just created one Kinesis stream of one shard. It's actually still in the creating stage, so it'll take a couple of minutes to create it. While that happens, let us go on to the next set of resources to be created. So I'll create a bucket called the AWS India webinar in S3. So let me go to the S3 service and have a look at if the bucket has been created. Okay, so it has been created. You can see that this is how the buckets basically storage placeholders look like in the console, and this is an empty bucket. Okay, so this is the bucket in S3 into which you actually can dump all the files, and that's where we'll be putting the files. Okay, as the next step, we will actually create the EMR cluster. So I'll first go to the EMR service to show you that we don't have any services currently running there. Yeah, so these are all former clusters that I have created for various purposes, but we don't have any running cluster over here. So I'll just create one cluster, and okay, so I've kicked off the creation of a cluster. Let's see if you can see it on the screen. Okay, so you can see that it's started the creation of a cluster called AWS India Webinar. This will take a few minutes to create, and let's create our last resource, which is creation of the Redshift cluster as well. And let's go to Redshift as well and see if we have any clusters there. Yeah, which is we have one cluster which is my internal cluster which I use for various purposes. We'll create a new one for this purpose. Okay. And let me refresh the screen. Okay. So we've kicked off the creation of that cluster as well. Okay. So just want to note that with just 4 commands, we actually created a streaming ingestion service, Kinesis. If you want to know the equivalent of that, a very similar service in the open source world is Apache Kafka, which can also be used to ingest data or buffer data while you decide how to pull data off the queue, right? And what are we doing after that? We'll kind of try to simulate a creation of logs. So we have a program that we'll use. First step, we'll actually use that program to simulate the generation of logs, and we'll dump it into Kinesis. So because we don't have a real live website, we have to simulate that part. The next step is we'll actually use EMR and use Spark and Hive to actually process the data which has been persisted to S3. And last step, we will actually run SQL commands. We'll load the data in Redshift and run some SQL commands to arrive at some insights, and we'll also at the end of it try to visualize the data, because that's what you actually want to do. We actually want to see how the data looks like in a visual format, and that's what makes sense to most business users, and that's what we want to attempt to do. Okay. So let's see what the first step is. Okay. So we have to collect the data. So we actually have to we will do the generation of the data and dump it into Kinesis. So let's have a look and see if the Kinesis stream has been created. Okay. So the Kinesis access log stream has been created with one shard. This basically you can write to the stream at around 2 megabytes per second, and you can read off it at 1 megabit per second. If your data volume is much higher than that, if your data volume is 200 megabytes per second or 200 gigabytes per second, you just need to add the number of shards that you need, and you can ingest that kind of data. And so first let's first create some data and ingest it into the cluster. So yeah, so I have so there is a file here called access log1. So I'll just show you what the file looks like. So it's for people familiar with Apache logs, this is a plain Apache log. So we will actually read from that log file and dump that data into the Kinesis stream. Okay, so we're now writing data into the Kinesis stream. Right, and while that happens, let's have a look at our EMR cluster. Yeah, it's still starting up. So while that happens, you can have a look at the log file format and what we are doing here. So basically, this is a standard Apache log, but in many cases, you may have different types of logs itself. You're pulling data from different web servers or web server types. You may not want all this data that you actually see there. You might want to just get a subset of the data, or you might want to actually group the data differently. And that is what we're kind of doing. We'll ingest this data in its native format. We'll pull it out and we'll pick out some columns that we actually need. We are interested in some characteristics of some of the columns that are there, and we'll visualize that data at the end of by the time we finish this application. Let's have a look at so the EMR cluster should be up any minute now. It usually takes 6 to 7 minutes. And while that happens, let's look at the Redshift cluster. Okay, so the Redshift cluster is up and running. It is a one node cluster, but you can have multi-node clusters if you want. So while that happens, let's take okay, so if you drill into this, you can see that this is the DNS entry of the master node of the Hadoop cluster. So people not familiar with Hadoop, like I said earlier, has got a master node and got data. It also has data nodes where the actual execution happens. So we actually connect to the master node, and then we actually execute all the commands that we need. So I'm just giving the DNS entry of the master node that just got created, and I'm going to log into that master node machine. I'll just make that a little big. Okay. Okay. So you can see that the cluster has gone into a waiting state. What waiting state means is that it is basically now waiting for inputs. When I launched the cluster, I launched it in an interactive mode by which you can actually log into the cluster and fire commands at it. If you're just processing data, you don't need to do this. In EMR, you can actually just automate the spin up of the cluster and have all the processing that has to be done, and the cluster can process the data and just terminate itself. That is also a very common way in which EMR is actually used. In this case, we are actually having an interactive mode so that you can actually see visually what we are actually doing while processing, right? So let me walk you through what we actually are going to do, and then we'll go ahead doing that. So we are actually going to use Spark, right? Like I said earlier, when Hadoop originally came, it pretty much was MapReduce running on data stored in HDFS or Hadoop distributed file system. Think of Spark as a much better MapReduce. It actually uses a lot of techniques to actually do things much faster. For example, it actually does a lot of these things in memory. All the processing, it leverages memory a lot to actually improve the performance. It also comes with many libraries. In this case, initially we'll actually use Scala as a language, but you can interact with Spark using various languages. You don't have to know a language like Scala or Python. You can also use Spark SQL. Like you see in the picture, there is Spark SQL. So instead of writing Scala code, you can also interact with Spark using Spark SQL, where you're writing SQL if you're more familiar with SQL. Right? And so even though you just know SQL, you can actually get the benefit of using a framework like Spark. And of course, there are other modules like Spark Streaming. There is support for Graph. There is machine learning and so on and so forth that are bolt on top of Spark. And that so we're going to use Spark as the framework. But the first step we're going to use is Spark streaming, which internally uses the Kinesis client library. So basically, what is a Kinesis client library? So for data that is in a Kinesis stream or which is in a buffer, you want to actually pull data off that stream, right? And you need a client. You can always query the data directly. The Kinesis client library helps you in querying the data. If you have many shards, it kind of keeps track of which data was pulled from which shard. It has support for things like that. And Spark Streaming uses the Kinesis client library internally and pushes data into S3. Right. So we have now logged into the master node, and what we're going to do after that is we're going to download the Kinesis client library, and we're also going to fire a few commands, and we'll get into the Spark shell. Okay, so let's go back to the cluster. Okay, so let's get the Kinesis client library. And all of this is actually available. All of what I'm showing you right now, all the code and everything will be available. It will be made available to you, so you can actually try this out yourself later. So I just downloaded the Kinesis client library. I'll set a few configs. And I'm starting the Spark shell. Okay. And after that, what are we going to do? We essentially are going to we'll fire a little bit of this code. So you don't have to get, if you're not from a programming background, though, it's fine. This is pretty simple code, or there are other ways you can actually, like I said earlier, you can interact with Spark via SQL as well. But this is just for the sake of this example. So we'll initiate a few variables, and we'll also set some other variables. For example, we have actually set a variable here on screen that is the name of the stream name, the Kinesis stream name. Also, we'll provide the Kinesis endpoint, and we'll also set the value of the S3 bucket. So what we're going to do in the next few steps is actually we're going to use Spark Streaming to query data from the Kinesis stream and dump it into the S3 bucket. That's what we're going to do with this code that you see on screen. Okay, so let's go back and get that going. Okay, so if we import some libraries, we'll set up some variables. So if you remember, we had set up the S3 bucket name. Let's have a look at the S3 bucket name. It was AWS India webinar. So hyphen and we have deployed this in the US East region. If you are going to deploy it in a different region, you'll need to change that endpoint. Okay. So in the last step, we actually looped through the RDD. RDD is the way Spark actually defines data, and we have attempted to write it into the S3 bucket. Okay. Yeah. So in the bucket, as you can see, a folder has been created, and it has been kind of partitioned into year, month, and so on and so forth. So it has pulled data from the data that was actually pushed into the Kinesis stream, and we have populated the data into one folder in S3 in the S3 bucket called access logs raw, which is the raw access logs. And let's have a look at the logs itself. So if you look at, you can list the logs if you want. Yep. So now moving from Spark and Scala, let's go straight to Spark SQL. Right. So now we have actually used Spark Streaming to pull the data and push it into S3. Now we're going to actually use Spark SQL to kind of transform the data further and log it again and persist it back after processing back into S3. Okay. Okay. So we have started Spark SQL. So Spark SQL, for people who have worked with Hive, it's basically the SQL interface. One important thing to note here is that if you're familiar with Hadoop, you probably are using HDFS to store the files, basically to store the data. If you're using EMR, or you can actually load binaries from ENR into your own cluster to actually do this, you can actually use S3 as the storage endpoint, which is actually a very important concept. Right? So instead of using HDFS, you can use S3, and you have decoupled storage from compute. And that allows you to independently scale your storage and your compute with comparable performance. Right? So in this case, we are actually going to create an external table with the storage as S3. And it is the same folder into which we actually dump the data. So that's what we're doing. We're creating an external table, and we are saying that the storage is in AWS India webinar, in the AWS India webinar bucket. Right? So let's create an external table. Okay, so the table has been created. Now let us have a look at the table. So let's populate, get all the partitions added, and let's have a look at one row. I'm doing a select star, but just one row. Okay, so I got one row, and So you can run normal SQL statements on it. Like you can actually do a count star if you want. So this is doing a count star, and essentially there are roughly 39,000 records in that table. Okay, but this can, so that's just for a demo, but this can also be billions of records if you want, and Spark SQL will scale to actually query that table. So now let's create one more table in the same place called access log processed. The first one, if you remember, was access log raw. Okay, so we create one more table. We'll set some more parameters. So we're going to select from the raw table and process it and dump the data into the new table, which will have the process data. Let's have a look at the S3 bucket. Okay. Okay. So it took a few seconds. So we have processed the data and we have actually dumped the data into a new folder. So we kind of, you can see that we have actually changed the format. Originally it was different. We kind of split up the data into a different format that we actually wanted. And from here, let's go to let's recap what we've done so far, right? So we use Spark SQL to process the data and put it into S3, and then we are going to actually load it uh, into Redshift. Right. So first we have to connect to Redshift. You can connect to Redshift using any any client that actually supports the Postgres drivers. There's also we have a very good tool that's the Agility Workbench from one of our partners. That a very good visual interface, but it only works on Windows. So I'm going to use the SQL Workbench to connect to Redshift. And then what we are going to do is we are going to actually create a table in Redshift and use the copy command in Redshift. So copy command is the command used to load data from S3 into from S3 into Redshift. You can also copy it from another Hadoop cluster or from a dynamic table, but in this case our data is in S3, so we can use the copy command to load the data into Redshift, and then we'll run a few queries on Redshift, okay, to figure out some of the things. So I'm going to go to the SQL Workbench, and to connect to it, I have to get the I have to go to Redshift and get the JDBC connection string. You can see I'm basically connecting the AWS India webinar cluster, which I just created a few minutes ago. And if you remember, we used the username password is master and India webinar. Okay. Oops. Okay. So I'm going to create a table called access logs. So the table has been created. And if you do a select star from access logs, there is nothing in it currently. So we have to actually copy the table from the S3 bucket. So the S3 bucket is AWS Okay, so now let's see if you have record. So you can see that yeah, we have now loaded data into Redshift, right? And let's try a few queries, right? Let's see. So basically, what have we done here? Let's recap again quickly. We had data coming into a Kinesis stream, which is a buffer in which you store your incoming streaming big data. In this case, it is web server logs. It can be anything. It can be clicks from your mobile app. It can be any web server log. It can be data from your IoT application or IoT devices, temperature data, you name it. It can be pretty much any data that's coming in, and it can get staged in Kinesis, which is a incoming buffer. From Kinesis, we actually pull the data using an EMR cluster and Spark streaming, and persisted the data into S3, which is persistent storage. From there, we further use Spark to actually process the data into format which we wanted, and later we actually copy the data from there into Redshift, right? So let's see what kind of queries do we actually want to run on Redshift. So you can actually yeah. So let's find some examples, right? So you want to actually find the distribution of status codes over days. So if you notice the log files, no, it basically the web server logs, for people familiar with web server logs, it has various status codes of the request. So some requests may a good request gives a status code of 200. Bad requests can be errors can be 500 errors or 400 errors and so on and so forth, right? So let's run these queries on Redshift. Yeah, so here you can see over a period of time what are the status codes, right? Let's try some other requests. So let's see how many status codes are 404 errors. So 404 is the page not found error. So the end user asks for a particular page, and that page is not there, or the referred page is not there. So you can see out of 30 to 40,000 odd records, around 1,000 records are actually, or 977 records actually have a status of 404. So I want to find out exactly which request is actually causing most of those 404s, right? So I'm going to run a query that says select top request, and I'm counting where status code is 404. Okay, so out of the 1,000 odd requests that had errors or 404, the top one out of 398, almost 400 of them came because the fave icon, or if people who don't know, that's basically the icon that comes on top of your browser. It typically is in the root directory. That particular file is not there, and that's where most of the 404s have come, right? But so that's a very simple insight. It's not very complicated. But let's, you really can't send this query to your business analyst or your CIO, right? You have to actually show it in a little different format. So what we've done is written a simple page which will actually run the same query that we ran. And so I'll give the name of the Redshift cluster to the page. This is the Redshift cluster that we gave, and I'm going to give a username password. And we're going to query it. Oops. Okay, so the exact same inference that we actually got here from a query, we basically are getting in a visual format. So this for your information, this page that I'm showing here is actually not hosted on a web server. So I'm not running a server for this. I am using a combination of static websites in S3. So S3, apart from being just a storage, can also host your static websites. And the backend, I am actually calling a Lambda function, and Lambda is another service from Amazon, which where you can actually, you don't need to run a server. It is just you can write your function and call that Lambda function, and it will execute for you without actually having a server. So we call this serverless architecture, which is becoming more and more popular. A lot of customers are also using it. So with very little, without even running a server, I'm able to actually show insight into the application, right? So as you can see, let's actually have a look at what we did again, right? So we had the logs, we ingested data into Kinesis. From there, we processed data and using EMR persisted it into S3, where we did further processing, and then ingested the data into Redshift, and then created a visualization at the very right. One insight we found, you can see at the bottom of the page, so we got to know that if we fix the fave icon, that would actually fix around 398 of the total 977 page not found errors. So that is a very simple business insight, but it is an insight. You can of course use these building blocks, and as you can see, it's very simple to actually create these building blocks, and you can create far more complicated big data applications using these services. And we did all of this in less than 1 hour. And so you can see how easy it is to actually get started with your first big data application using the AWS services. Right? So, and we visualize these results as well. Apart from using JavaScript, we also have the QuickSight service, which is actually currently in preview, which you can request for, and you can request for a preview if you go to the website. Or you can use any visualization tool to actually visualizing tool that supports JDBC or ODBC to actually query Redshift. So with that, I think we just have 10 minutes, and the best part is that all of what we did now, which is creation of a Kinesis stream, and creation of S3, using EMR and Amazon Redshift as well. And Redshift is actually also, if it's a new account, has a 2-month free tier if used. So even you can also avoid the Amazon Redshift cost as well. But this is the cost of whatever we did today. Will actually come to your bill. So it is not expensive to even try out as well. That said, I'm going to move over to questions and see if how much ever I can answer them. I hope you've already put in your questions into the chat window.